Welcome to True Projects. In this video, we are going to explain about the project that is heart disease prediction using novel ensemble and blending based cardiovascular disease detection networks, that is ENS CVDD-NET and B1 CVDD-NET. Before getting into the execution, first let us understand what is the project about. So, cardiovascular diseases or CVDs are a huge problem worldwide. Honestly, they are one of the leading causes of death. About 32% of global deaths are due to CVDs. And what is even scarier is that most of these, around 85%, are because of heart attacks and strokes. It is pretty alarming when you think about it, right? These diseases mess with the heart and blood vessels, which are obviously crucial for our body's functioning. If something goes wrong, it can lead to long term health issues, or in the worst cases, it leads to death. What makes even worse is that growing number of cases related to this heart diseases and hospitals are feeling strained. Early detection is so important here because if we catch these problems early, we can manage them with medications or lifestyle changes and avoid those invasive treatments like bypass surgeries. And let it be real, our lifestyle choices play a huge role in this. Things like eating junk food, not exercising, gaining weight, and having conditions like high blood pressure and diabetes all adds up. It is like domino effect that just keeps raising the risk. That's why it is so important to focus on prevention and catching the signs early. It can really make a big difference. So predicting the heart disease is actually pretty tricky because the main reason is that medical data is super complex and varies a lot from one patient to other. You're dealing with so much diversity, different symptoms and health conditions and even lifestyle factors that affect how diseases show up. This makes it hard for machine learning models to pick up one clear patterns, especially when the data is imbalanced. For example, in many data sets, you will have way more cases of people without heart disease compared to those with it. And the imbalance throws the predictions off. So now the methods like SMOT, that is synthetic minority oversampling technique which try to balance the data by creating synthetic samples, but honestly sometimes that just adds up more noise instead of helping. And then we have some advanced models that are convolutional neural network and bi-LSTMs, which are really powerful, but they come with their own issues. These models are super resource intensive. They need a lot of computing power and they are sensitive to how we tune hyperparameter settings. Plus, they can be slow, which isn't great when you want quick predictions. So there is real need for systems that need to handle all these challenges, ones that are not just accurate but also efficient and scalable. The goal is to clearly make early prediction, early detection easier and more reliable so we can manage heart disease better and reduce its massive impact on global health. So, the whole idea behind this project is to make predicting heart disease a lot more accurate and efficient by using some advanced techniques in deep learning. The first big issue we are tackling with is data imbalance. In lot of medical data sets, we will find that there are way more healthy people than those with the disease, which can throw off the predictions. To fix this, we are using something called adaptive synthetic sampling technique. So, this helps in balancing things out by generating synthetic data points to make sure we have a fair representation of both healthy and sick individuals in the data set. Then we select the important attributes using the correlation analysis. So, we use correlation analysis to select the important ones. Then there comes a proposed system where CVDD-NET and BiCVDD-NET are the two proposed models of this project. So coming to this NCVDD-NET, it is combination of two powerful architectures where LeNet, which is type of convolutional neural network that is great for extracting features, and GRU, which is a type of recurrent neural network that is RNN, that is good at understanding sequences like time series data. Coming to the second model that is BiCVDD-NET, it uses similar setup but adds an artificial neural network to bring even more flexibility and power to the prediction process. These combined models are designed to make the prediction process smarter, handling complex data more effectively. And these models are evaluated using accuracy, precision, recall, and F1 score. So these are the right metrics to evaluate all the classification models. All these metrics together show how effective the model at tackling the challenge of predicting heart disease. And here, the real strength in the system lies in its ability to automatically learn the right features from the data without needing a lot of manual work. It can handle large, complex data sets with ease, which is key when dealing with something as intricate as heart disease prediction. To further improve the accuracy in this project, we have incorporated multiple ensemble models that are voting classifier, and CNN with bialistium. So coming to voting classifier, it is basically takes the predictions from several different models and combines them to give a final result that is more trustworthy. This helps to reduce the errors that might come from a single model's weakness. On top of that, we have also combined CNN and LSTM, that is convolutional neural network and long short-term memory networks, in a hybrid approach. It is great for extracting features while LSTM handles sequential nature of the data, so bringing both together really boosts the system's ability to predict cardiovascular disease more effectively. Furthermore, we have also built front-end using Flash framework. This allows users to interact with the system in simple, intuitive way. This interface includes a user authentication feature, ensuring that only authorized users can access and use the system. This addition makes the whole system much more practical, and it gives users a secure, easy to navigate platform and to test deploy the model. And coming to the implementation of the project, so first we have imported all the required libraries that are pandas, numpy, sklearn, tensorflow, which are required to manipulate the data, build the models, and create the web interface. Then comes exploratory data analysis part. So in this step, we load the data set that contains information about heart disease patients, and we analyze its structure and gain insights into the data such as features and labels to understand what we are working with. Then comes data processing. Here we clean the data set by handling missing values, encoding categorical variables, and ensuring that the data is in a proper format for training the model. Data visualization. So this step involves using graphs and charts to visually explore the data, helping to identify patterns or relationship between features and the target variable. Selecting X and Y data. X represents the feature data that has input variables, and Y represents the target variable, whether the patient has disease or not. In this step, we separate two sets, that is data for training the model. Coming to data sampling, so here we use ADASN oversampling, that is adaptive synthetic sampling technique. So this technique is used to balance the data set by generating synthetic data points for the minority class, ensuring the model doesn't is not biased towards any majority class. Splitting the data set. So here we split the data into training and testing sets. We usually split the data into 80 is to 20 ratio, where 80% of the data is to train and 20% for testing. Coming to building the model, so here we initiate all the models that we will be developing. We will define the architecture and the layer of the model. And after defining the model that we will be trained with the training data, the model learns from the patterns in the data to make predictions about the heart disease. And that will be evaluating using accuracy, precision, recall, and FN score. And we will compare them through graphs. Then coming to the part of front end, so the Flash framework is used to build a web interface where users can input their data. SQLite is used to store the user information, and the front-end interface integrates the train model and allows users to enter the features. And in the front end, users they can input their features related to age, blood pressure, etc. in the front end, and that will be pre-processed at the back end. It will be fed with the train model. Finally, outcome will be displayed in the front end of the application. So this is how we have implemented the project. Moving on to the algorithms used. So these are the algorithms used in this project. So this is the extension model, and these both are the proposed model for predicting the heart disease. And to implement this project, we need basically hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework Flask, backend framework Jupyter Notebook, database SQLite 3, front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in the templates folder, we have files containing HTML pages used in the project. Typically includes files like index.html, about.html, etc., which represent different pages of the website, and app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the model file in which we have the algorithm information stored, and that will be loaded into the project code during runtime of the application. And this is the data set that we have used in this project. It's being loaded. Just wait for a while until the data opens. Let's check with the other files. So this is the notebook.ipynb file. This is a Jupyter notebook file which contains which contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. And this is the sample file in which we have test cases that we will be using in the front end for predicting the heart disease. Dataset has been opened. Let's open it. So these are different input features. So this is the data set, and these are all the features which influence the heart disease. And this data set, we will be using it, we will be reprocessing it, and then we will train it with the models. Let's close this. So now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, and now click on enter. So current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on click here. Give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see inputs, right? These are the parameters need to be given as the input. Based on that, we will be getting the prediction of heart disease. Let us understand each of them. First, we have high BP, that is high blood pressure. This indicates whether the person has high blood pressure, that is hypertension. It is a risk factor for heart disease and stroke. If the value is 1, it means that person has high blood pressure, and 0, they don't. Then we have high cholesterol. So this shows whether the person has high cholesterol levels, which can contribute to the heart disease. Then we have cholesterol check. So this represents whether the person has had their cholesterol levels checked in the past 5 years. So the next parameter we have is BMI, that is body mass index. It is a measure of a body fat based on height and weight. A higher BMI can be a sign of obesity, which increases the risk of heart disease. And the next one we have is a stroke. So this indicates whether the person had or has a stroke, where 1 means the person had a stroke and 0 means they don't have. Then comes diabetes. So here it shows whether the person has diabetes or not. Then we have HBY alcohol consumption. So this indicates the person consumes alcohol heavily. And then we have Gen Health. So this refers to the person's general health status. Typically, it is rating from 1 to 5. And the last one we have is diff walk. So this indicates whether the person has difficulty or climbing stairs, difficulty in walking or climbing stairs. So this is about the parameters. Now let's enter them. For that, open the sample file in the code folder. Open it. So these are the different test cases that we will be using now for predicting a heart disease. So let's start entering. So let's try the first case where high BP is 1, high cholesterol is also 1, cholesterol level is 1, body mass index is 34, stroke is 0, diabetes is 0, gen health, sorry, heavy alcohol is also 0, and gen health is 2, difficulty in walking is 1. Now let's click on predict. So this given input, it will be pre-processed at the backend and then trained model will be giving us a prediction. So here we got the prediction that patient is diagnosed with heart disease. So here class 1 refers to patient has heart disease. It is correctly classifying that patient has heart disease. Now let's try with the second case. So here the first two, that is high BP is 0, high cholesterol is 0, cholesterol check is 1, 34 is the body mass index, stroke is 0, diabetes is 0, gen health is, sorry, heavy alcohol is 0, gen health is 3, and the next value is 0. Now click on predict. So let's see what will be the prediction. So here we got the prediction that patient is not diagnosed with heart disease. So it is correctly predicting that patient is not having any heart disease. Let's check with two more cases. So let's try with this one. where the first two, that is high blood pressure and high cholesterol, is 1, and cholesterol check is also 1. Body mass index is 28, stroke is 0, 2 is diabetes, heavy alcohol is 0, 4 is general health, and difficulty in walking is 0. Now click on predict. So here we got the prediction that patient is diagnosed with heart disease. That means patient is having the heart disease. Now let's check with one more case. So now let's check with this case. So where high BP is 1, high cholesterol is 0, cholesterol check is 1, 48 is the body mass index, and 0 is the stroke, diabetes is 0, heavy alcohol is 0, general health is 4, 0 is difficulty in walking. Now click on predict. So here we got the prediction that patient is not diagnosed with heart disease. That means patient has no heart disease. Let's try with one more case. Last case. So let's try with this case where high BP is 1, high cholesterol is 1, cholesterol check is 1, 46 is body mass index, stroke is 0, 2 is diabetes, alcohol consumption is 0, general health is 3, and 1 is difficulty in walking. Click on predict. So here we got the prediction that patient is diagnosed with heart disease. That means patient is having the heart disease. If you observe, we got the correct predictions. Now let's check with the graphs. Click on graph. So here we have the graphs. So this is the outcome distribution. Here on x-axis we have target class, and on y-axis we have the count of each class. So this is the target class distribution graph, where one class is 0 and 0, one class count is less and 0 class count is high. Here 1 refers to people with heart disease, 0 refers to people with no heart disease. That is why we have used adaptive synthetic sampling technique to address this class imbalance issue. And this is the correlation matrix graph, which shows the correlation between variables. And this is the accuracy comparison graph. Here on x-axis, we have accuracy score, and on y-axis, we have all the algorithms trained. And this is the precision score comparison graph. This is the recall score. This is the F1 score. Now click on sign out. So in this way, just by giving inputs to the application, it will predict whether the patient has heart disease or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.